Bismillahirrahmanirrahim. In this lecture, we are solving a problem for HVAC heating, ventilation, and air conditioning. So, the statement is a heat pump operating on vapor compression cycle uses refrigerant R22 for space heating. The various state points of refrigerants are shown on the TS diagram. This is from 1 to 2. This is compressor, and a compressor work input is done. And from 2 to 3, this is condenser, and condenser heat is rejected. Heat is rejected. 3 to 4 is expansion wall. This is isenthalpic process, and for 4 to 1, this is evaporator, and evaporator heat is supplied to the system. So first I write given data. So in given data, lower temperature and low temperature and pressure region, temperature is given to us is 10 degrees centigrade. So T1 is equal to 10 degrees centigrade, and this is high temperature region. After compressor, the region is high temperature region, and high temperature T2 is given to us as 50 degrees centigrade, and refrigerant use is R22. Refrigerant use is R22. So this is the given data. Now required is there is some required in the problem. Number 1 is refrigeration effect. Number 2, this is the part of this problem, refrigeration effect. Number 2, second is work of compressor. Third is heat rejected in the condenser, Qout. Number 4 is COP of heating. Our number 5 is ton of refrigeration. These things are required. So in required, we are writing required things. Number 1, refrigeration effect. Number 2, work of compressor. Number 3, heat rejected in the condenser. Number 4, coefficient of performance of heating. And number 5, ton of refrigeration. So, and there are some assumptions in the problem. Assumption number 1 is at state 1, evaporator pressure is given to us as 10 degrees centigrade. At state 1, evaporator pressure is equal to evaporator temperature. Evaporator temperature is equal to 10 degrees centigrade, and this point is saturated vapor. Because this line is saturated liquid line, so state 1 is saturated vapor point. Saturated vapor. Assumption number 2, at state 3, temperature is equal to 50 degrees centigrade, and this is point state 3. and this is saturated, this line is saturated liquid line. So this point is, at this point the refrigerant is saturated liquid, saturated liquid. Similarly, process 1 to 2 is isentropic. Process 1 to 2 is isentropic. This is from 1 to 2, this process is isentropic. Process 1 to 2 is isentropic. Isentropic means that S1 is equal to S2. And assumption number 4 is process 3 to 4. Process 3 to 4 is isenthalpic. Isenthalpic means that H3 is equal to H4. Now we start solution of the problem. So number solution of first, in first one we need refrigeration effect, and this is equal to H1 minus H4. First we find H1 and H4. So we know that point 1 is saturated vapor point from assumption number 1. So from saturated table, of R22, from saturated table of R22, at temperature T1 is equal to 10 degrees centigrade. H1 is equal to Hg because this is saturated vapor point. So H1 is equal to Hg is equal to 408.76 kilojoule per kilogram, and S1 is equal to Sg 1.7377 kilojoule per kilogram per Kelvin. For for H4 we find H3 because in assumption number 4 H3 is equal to H4 isenthalpic process. So now we find H3. So from saturated table of R22 at T2 high temperature region 50 degrees centigrade, H3 is equal to HF, and H3 is also equal to H4 because this process is isenthalpic. This is equal to 262.27 kilojoule per kg. Now we can find refrigeration effect, which is equal to H1 minus H4, which is equal to H1 is equal to 408.76 kilojoule per kilogram minus H4 is equal to 262.27 kilojoule per kg. Kilojoule per kg. So refrigeration effect is equal to 146.49 kilojoule per kg. So for 1 is solved. Now we are solving for number 2, solution of number 2. In solution number 2 we need work of compressor, and work of compressor is equal to H2 minus H1. So first we found H2. H2 is in superheated region. We see in TH diagram that form 2 is in superheated region. So we will use superheated table for R22. So and S1 is equal to S2. This is assumption number 3. Work of compressor. This is isentropic process. So S1 is equal to S2 is equal to 1.7 1.7 377 kilojoule per kilogram per kg per Kelvin. So from superheated steam table, table of R22 at pressure is equal to at temperature is equal to 50 degrees centigrade and entropy is equal to 1.7377 kilojoule per kilogram per Kelvin. H2 is equal to 470 kilojoule per kg. So work of compressor is equal to H2 minus H1. H2 is equal to 470 kilojoule per kg minus H1 is equal to 408.76 kilojoule per kg. So work of compressor is equal to 61.24 kilojoule per kg. So point number 2 is solved. Now we are solving point number 3, heat rejected in the condenser. And number 3 we are finding heat rejected and the condenser. So this is Qout and Qout is equal to H2 minus H3. So H2 is equal to 470 kilojoule per kg minus H3 is equal to 262.27 kilojoule per kg. So heat rejected in the condenser is equal to 207.73 kilojoule per kg. Now we are solving part number 4. So in part number 4, coefficient of performance of heating is needed, which is equal to heat rejection in output divided by input. Output is heat rejected in the condenser divided by work of compressor. So heat rejected in the condenser is 207.73 kilojoule per kg and work of compressor is 61.24 kilojoule per kg. Kilojoule per kg will be cancelled with this, and coefficient of performance of heating is equal to 3.39. Now we are solving part number 5. So in part number 5, ton of refrigeration is needed. So first we find heat in kilowatt. So this will equal to m dot mass flow rate into refrigeration effect. Mass flow rate is given to us is 0.025 kilogram per second and refrigeration effect is 146.49 kilojoule per kilogram. So Qn is equal to 3.66 kilowatt. Now ton of refrigeration is equal to 3.66 kilowatt divided by 3.517 kilowatt. So because 3.66 divided by 3.517 ton of refrigeration, because 1 TR 1 ton of refrigeration is equal to 3.571 kilowatt. To convert kilowatt into ton of refrigeration, divide by 3.517. So ton of refrigeration is equal to 1.04 ton. So problem is solved, and for more videos please like and subscribe my YouTube channel. Thank you.